Right, next two questions. And remember, today's question is very, very important concept, today's concept. And this is the easiest concept. And if you are lucky, even you may expect a question in JEE mains, advanced, and NEET even. Okay. So that is what it is. It's very basic concept. Just only three concepts is remaining. So in that, today's concept is one. That is also about a graph, stress and strain graph. Already I have taught you this briefly, and today we are going to study in detail. And then potential energy stored. After that, almost this chapter is over. So definitely 100% tomorrow and after tomorrow, mostly 99% will finish this chapter. Okay. Understand, brothers, what I'm saying? So now let us start the next question. So till now we have studied the three kinds of modulus we have. So elasticity of modulus of elasticity three. One is Young's modulus. Next one is what? Shear modulus. And another one is what? Everybody? Bulk modulus. Am I right? All of you? Yes. So if you have noticed it, bulk modulus is related to some kind of thing. What is bulk modulus? Anybody can tell? All of you? Please respond. Volume stress divided by what? Volume? Volume strain. Which is called as a bulk modulus. See, involvement of class is very, very important. You have to solve. This is your class. That is, you should remember and solve. So next question, I think question number 8 it is. So write it. Average depth related to bulk modulus. Average depth of Indian Ocean is about 300 meters. Calculate the fractional, but remember the concept, whatever I taught regarding bulk modulus, you have to remember. Because volume stress is equals to something, force by area which is equals to something. If it is a liquid, so we have studied that. What is that, anybody? Volume stress is equals to force by area is equals to something. Anybody remember? Fractional compression. Tell me guys, I'm asking you. Force by area volume stress is equals to something, Pradosh. What is that? Compression delta V by V of water at the bottom of ocean. So I'm giving G value. At least notes you can refer, you will find it. You have written F by V, F by A equals to something. Pakranga. Volume stress sigma equals to something. This much, what is this? So density of water is 10 power 3 kilogram per meter cube, and bulk modulus of water is 2.2 into 10 power 9 Newton per square meter. Volume stress sigma equals to F by A is equals to something you have written. See the notebook and tell me. That's what I'm asking. I'm not asking anything else. Okay, anyhow. You people are all dumb fellows, I know. You people will never speak. So average depth of Indian Ocean is about 300 meters. Calculate the fractional compression. They are asking delta V by V of water at the bottom of the ocean. They are asking. That is what at the 300. So now, you all people knows that. Generally, I am taking you. So pressure is equals to force by area. Pakranga volume stress you have written, force by area is equals to pressure. Written or not? Adimatada involved. Otherwise, I will stop the class. No problem. So next, same way, pressure exerted by fluids. 9th class you might be studied, or else if you're not studied also now you studied. Fluids means either by liquids or by the gases. So whatever it is, the fluid pressure formula is equals to density of a fluid into acceleration due to gravity into height of the fluid. This is the formula. At least do you remember this, everybody? Rho GH we used to call it as a fluid density formula. This is the fluid pressure density pressure formula. Pressure is equals to force by area. This is for solids and this is for liquids. Am I audible, people?
Yes, sir.
Then what I'm asking, you have not written, Laksha. F by A is equals to volume stress sigma equals to P. Delta P have written. Check it. So now they're asking, yeah, average depth of Indian Ocean is 300 meters. Now calculate the dV by dV. So delta V by V means in the sense of what? There is a ocean, you all notice it, and there is an object which is inside this water. So that is very important. Inside this water. Now, if it is go inside, definitely it will experience the force. That is what? Force by the liquid. So as this is the water. So as we know, some object is inside. Let me take some random shape. So now it is actually filled with what? It is inside the water means definitely it is having some air or something. Let me take it is present like gas, something. So now because of the pressure exerted by this liquid, that is what water on this object, that is what force per unit area, force per unit area. That's why I will get angry if you are what you studied also not saying means definitely I will be. So force per unit area, force per unit area. I like this every direction it will exert force per unit area. So that what will happen? The shape does not change, but finally what is happening? The volume will reduce or increase everybody. Volume will reduce. It will undergo compression. Am I right or wrong? Please respond. So that is what will happen. Now they are asking volume stress. That is what bulk modulus also they have given. And they're asking what is the compression? Delta V by V they are asking. So let us see how to find. So volume stress is equals to, we all knows that, force by area, which is equals to what? Pressure. And volume strain is equals to, can you tell me what is the volume strain is equals to formula? We have done already. Volume strain is equals to, please respond, delta V divided by delta V divided by V. And as we know, most of the cases, volume is reduces. So it will become what? Minus delta V divided by V. So that is what I will say. Bulk modulus B is equals to, so we all know what is the formula? Volume stress divided by, speak guys.
Volume strain.
Volume stress is P by F, sorry, F by A. So divided by, next one is what? This one, delta V divided by V. So we all know F by is equals to P divided by delta V divided by V, which is equals to what is the formula? PV divided by delta V. Am I right or wrong, everybody? Yes, please.
Yes, sir.
Yes, that is one. So please try to solve, everybody. Understand, Princey? So now we all knows that what is the depth of the ocean? They have given in the question. Everybody, what is the depth of the ocean given in the question? All of you. 300 meters. Am I right or wrong? That is what is the height. So we all knows that. You can notice it. What is the liquid pressure formula? Everybody, pressure exerted by fluid is equals to rho into G into H. Learn it. Rho means density of liquid. What is the density of water? Given question, if you observe, you will notice it. What is the density of water? All of you.
10 power 3
Power
kilogram.
10.
Next, what is the G value? 10 into. What is the height? 300. Am I right? So pressure at the bottom, which is equals to, I will write this one as a 3, 10 power 3 plus 1, 4 power plus 2, which is equals to 10 power, here 3 plus 3, how much? 6. Am I right? 10 power 6 Newton per square meter. Any doubt in this, you can ask me. If you have doubt, 300 I can write as a 3 into 100. Okay, Murali? 100 I can write as a 10 square. So 10 square plus 1, 10 square, 10 power 1, 3 plus 3, which is equals to 6. Okay, Murali, understand, Mr. Narayan? So that is the pressure at the bottom, right? So that's what. Now, what is the question they are asking? Observe very carefully. What we have to calculate? Delta V by V, which is equals to how much? Am I right, guys? Speak, guys. Everybody? All of you? So now B is equals to, we all knows that delta P rho P into V divided by delta V. So now delta V will come this side. I'll write delta V divided by V is equals to P divided by B. Will you all agree with me? Everybody? Yes or no? Respond, guys. So which is equals to change in volume divided by total volume is equals to P value 3 into 10 power 6. Okay, divided by bulk modulus. What is the bulk modulus given? Pakranga. Given question, what is the bulk modulus? Everybody. Bulk modulus, how much ra? 2.2 into 10 power 9. Okay. So at least that value you have to tell me correct. So 2.2 into 10 power 9. So what else remaining? 10 power 6, 10 power 9 get cancelled, 10 power 3 remaining. So 3 divided by 2.2 into 10 power minus 3 will go up. That is what? Delta V by V. So you can solve this one, you'll get the answer. Do it everybody quickly. So 3 divided by 3. Okay. Do it, make it quick. So 3 divided by 3.22, how much ra? 2.2, which is equals to, everybody, 1.36 into 10 power minus 3. So that is what is the delta V by D. Understand, Dreswa, Pradosh? Clear?
Yes, sir.
Yes. So that's what it is.
Yes.
Please note it. It's very, very important. And you all need to know it is compulsory. You have to solve this question. And one more thing I want to say here. All of you observe. Compressibility, there is a factor, you will get it in this chapter. If you want to calculate the compressibility, the symbol is actually B. So C, note it everybody. So if you want to calculate compressibility C, then note it, just do the 1 by bulk modulus. So you'll get the compressibility. That's all, guys. So learn this formula also. So 1 by bulk modulus will give us the compressibility factor. This is also one of the most important. I hope you all understand this question. Anyone having any doubt, you can ask me, or else we'll proceed further. Mr. Murali, Narayan, Pradeep, I don't need to call every time. You have any doubt, you can ask me. I will explain it. Do you understand or not, everybody?
Yes, sir.
Yes. So, suppose if they will ask us to calculate the bulk modulus. So, we all knows that bulk modulus means what will happen? Inside pressure is, outside pressure is P, inside pressure is delta, you can take it as a P naught. So, by the time, what is the bulk modulus? Suppose if it is this object is, if you imagine, this is a special case. If object is an air balloon, if I imagine, all of you remember, then in this case, outside pressure is P, inside pressure is P naught. So, by the time, bulk modulus P is equals to what is the formula? Delta P divided by minus of delta V divided by V, which is equals to delta P into V divided by minus of delta V. So this is the formula. We already studied on that day. We have been confused also, but this is the formula we have to remember. I hope you all clear. Anything doubt, you can ask me. Are you clear, everybody? So why this minus is coming? Always, most of the cases, volume is what? Decreasing or increasing? It is decreasing. That is why you have to remember that. Understand, Princey? Narayan? Very, very important. Note it. I love it. Brothers, clear? Mr. Rishi? Do it. So, this is what is about the bulk modulus. So, very, very important. So, now bulk modulus and volume. That's what, yeah. Bulk modulus and as well as first modulus. What is the first modulus? Everybody, gamma. Call it as a Young's modulus. Over. So now we'll solve one question related to the shear modulus. So that is very, very important question. So after that, we'll go to the next concept. I hope you all are clear. Any doubt in this, you can ask me. Mr. Kadir, Rudresh, I'm asking you again. Are you clear? Yeah. So write the next question. Any doubt, Pradosh, Laksha, Princey? So last question regarding this modulus of elasticities. So that is what right next question. A square lead or lead slab of side 50 centimeter, note it very carefully, and thickness 10 centimeter is subjected to a shearing force 9 into 10 power 4 newtons. How much upper edge will be displaced? So from this question, what you have to calculate, try to remember the shear stress and tell me how much edge is displaced they are asking. What does it mean? You have to calculate what? Anybody can tell? From the question. Yes, Rudresh, Pradosh, Mr. Narayan. How much upper edge is displaced? So what do you have to calculate? Try to remember the shear stress. What is shear stress? Do you remember? The force is applied. Shear, that is what tangentially. Then what will happen? Just from the original position, it has been inclined. Remember, Ara? So what is that? How much upper edge will be moved? What is that representation? Everybody. Yes. Delta X and height of the cylinder H, I will take it. Then tan theta is equals to delta X by H. Am I right, Pradosh? Remember? Yes, everybody. We want to calculate how much upper edge will be displaced. Yes, we have to calculate what? Everyone. We have to calculate the delta X. Understand? So we have been formed a right angle triangle also. Do you remember, everybody? So right angle triangle means what will happen? Adjacent, this is delta X and H. So which is equals to adjacent side by opposite side. That is what is the tan theta. Am I right, everybody? Tan theta is equals to dx by h. But theta is approximately small, very, very small. Then tan theta is equals to what, everybody? Tan theta is equals to theta. We have to remember that. We have written or not? Yes or no? We studied or not? Yes. Write the question. How much upper edge will be displaced? If shear modulus of elasticity G is equals to 5.6 into 10 power 9 Newton per square meter for lead. So that is what is the question. So you have to find the delta x. So how to solve? It's not easy thing. We will solve it. So we all knows that if a cylinder is applied, first shear stress, tell me shear stress and shear strain. First shear stress, tell me, everybody. All of you should tell SHER, shear stress. I'm asking you now. What is the shear stress? Applied force tangentially. So let me take it as a FT. Tangentially we are applying at the edge. So applied force is FT divided by, what is the area? Area of cross section. This is what is the shear stress. Now shear strain sollunga, Sigrama. In board itself it is there. What is the shear strain? All of you. Shear strain is equals to
Delta X by H.
which is equals to tan theta, and we all know approximately it is equals to what? Everybody, theta. All should knows. Understood? Now they are asking delta x. Delta x means we'll calculate it. So what is that, everybody? Shear stress. Sorry, shear modulus. Shear modulus is equals to what, everybody? Shear stress divided by shear strain. So shear stress is what? FT divided by A. Shear strain is what? Delta x divided by h. So that's all, everybody. If you focus it, you will get it. This formula, FT tangential force into h divided by A into delta x. So this is the formula we'll obtain. Any doubt, anybody can ask me. Are you clear, everybody? All of you?
Yes, sir.
Please note it one more what I'm saying. What do you mean by G? Anybody can tell? Shear's elasticity. Am I right or wrong? Shear's elasticity. Also call it as this one, modulus of rigidity. Please note it. Modulus of rigidity. Rigidity is call it as a rigidity. R-I-G-I. Rigid. Rigidity. T-I-T-Y. So rigidity, that is what modulus of rigidity we used to call it as. Modulus of rigidity is one, also call it as a what? G we used to call it as. Okay, guys, please respond. So now I can proceed. So we all knows that delta x by h, which is equals to what? Just now we studied. Delta x by h, which is equals to what, guys? All of you tan. So remember. Yeah, if it is extremely smaller, then we will consider as equal to theta. So forget about it now. So now we got the formula FT tangential force into height of that divided by A into delta x. Now, all of you imagine. So there is a starting square lead slab of side 50 centimeter and thickness 10 centimeter. So square lead slab I am taking. So let me take a cuboid, which is actually a three-dimensional of a square. So I am taking it and I am saying, according to the question I am writing. So what the question they are saying? So 150 centimeter, sorry, 50 centimeter. What is that, everybody? 50 centimeter is a what? Side. Do you understand, everybody? And what is the width? Width, anybody can tell? What is the width of this? Width of this is equals to 10 centimeter. Understand, brothers? Everywhere width equals to. So now it is attached, it is kept on the surface, or it is pivoted on the surface. That is very important. Pivoted or according to 11th class, riveted or riveted, you can say riveted or pivoted. Both means it is stick to the surface. That is the meaning of it. So now if I find the shear stress, what is the shear stress formula? Anybody can tell? Shear stress formula, F divided by A. So F value they have given. What is the applied force? Laksha, 9 into 10 power 4. So applied force is that 9 into 10 power 4 divided by what is the applied area? Pakranga, 50 into 10. How much is the area? Area 50 into 10. Area is equals to 50 into 10, which is equals to 500 square centimeter. But we can substitute in square centimeter. We must convert into square meter. Everybody, square meter. Yes, Manya, tell me 1 square centimeter equals to how many square meter? 10 power minus 4 square meter. Please learn. 1 square meter equals to 10,000 square centimeter, and 1 square centimeter equals to ulta 10 power minus 4. Understand, Manya, Samya?
Yes,
So that's all, which is equals to, I will write 50. So 50, 500 means 50. So 50 into, I can write, sorry, 500, correct? So 500 into 10 power minus 4. That is what area. So area means square meter will come. So what will happen, everybody? So Newton per square meter. So shear stress is equals to 50 actually, not 500, sorry. So 5 into 10. This is 50, correct, guys? What is the area? 50 or 500? 500 only, yeah? Yeah.
Sir, 500.
500 only. So this is 500. So 500 into 10 power minus 4. So I will write it 500 into 10 power minus 4. Now this minus 4 will go up. What will happen, everybody? Minus 4 will go up or down? Minus 4 will go up means it will become plus. So 9 divided by 500 into 10 power 4 into 10 power 4 will come up. Minus 4 will come up. It will become plus. So which is equals to into 10 power 8 Newton per square meter. Now this is alone. So all of you do it, everybody. So this is what shear stress. Then what about the shear strain? Anybody can tell? Shear strain formula, all of you. Shear strain is equals to delta x divided by, what is the formula? Delta x divided by height. What is the height? Side slab. What is the side slab, Amma? Side slab. Yenara, side slab how much, ra? Side slab how much? That is what I am asking.
50.
50 centimeter. That's all. So now you can substitute it over. So I can substitute the values, which is equals to shear stress is equals to, sorry, shear modulus is equals to F by A divided by delta X divided by H. So which is equals to what? F is equals to how much, ra? So we got, yeah, what we want to find it actually, they're asking. What is the delta X? So remaining all is substituted. F by A, we got it. How much answer, Amma? 9 by 50 means how much? So 9 by 50, 9 by 500 into 10 power 8 divided by delta X. Delta X divided by H is equals to 50. So which is equals to, what is the G value? Pradosh? G value is given how much? 5.6 into
10 to the power 9.
Yeah, 10 to the power of 9. So that is what you have to remember. Yeah, 10 to the power of 9. So you can do this one. You'll get the answer. So what will happen? You can notice it. So 9 divided by 500, you can see. So it will become 9 divided by 500 into 10 power 8 into this will come up 50 divided by delta.
50 by del x.
Which is equals to 5.6 into 10 power 9. So now you all can notice it, all of you. So what will happen, everybody? 10 power 9 and 10 power 8 will get cancelled. Here 1 will be there. Now 50 and 0 will get cancelled. 5 ones are 5 tens are. So next over. So here what is remaining? 5.6 into 10 power 1. So which is equals to, this is 9 by 10 into 1 by delta x. So now delta x will come this side. This I will write as a 56. So 56 is equals to 9 by 10. I'll write 0.9 into 1 by delta x. So delta x will come this side. So delta x is equals to how much will come, ra? 0.9 divided by 56. Am I right, everybody? Please respond, guys. All of you. Please do this one and tell me. So or else I will write 9.
0.0.
Yeah, into 10 power minus 1. Let it be, write it. So what is the answer? 9 by 56 means how much, Amma?
0.016.
0.016 into 10 power minus 1. So what is the delta x?
16.
Yeah, 16, Amma. Yeah, 16. So
0.016.
okay, ma. So that is the delta x. Delta x is equals to final answer, whatever you will get, you write it. So that is how you have to find it, delta x. So if anywhere we have done mistake, you tell me. So we have to make it any corrections. So that is what. Any doubt anybody can ask me. We'll proceed according to that. Understand, Pradosh?
Yes, sir.
Yeah. So do it, everybody. Completed? Everybody completed.
Yes, sir.
Completed, everybody. Tell me, 0. How much answer? So 0.1607 will come. So let it be 0. I'll write 0.161 into 10 power minus 1 meters. So write it as a 0.0161 meters. Write the answer, everybody. So that's all is that. Clear, everybody? All of you? Yeah. So this is what is about this numericals related to all modulus of elasticity, Young's modulus and shear modulus, and as well as bulk modulus. So definitely the bulk modulus, shear modulus, they will ask us to calculate what is the displacement. Delta x is how much. So that is only they will ask. So I hope you all completed that question. So even that NCERT also we have seen. So this delta x only they will ask us to calculate. So here what is the formula we have been done? Simply you have to remember two things: shear stress, shear strain. So shear stress is always same. So what will happen? Shear stress is equals to, so shear stress is equals to force by area. So now next shear strain is equals to what will happen? Delta x, and this height is, you take it as a L or H, whatever it is. So what is the shear strain? Delta x divided by H. So if you do both, we'll get the shear strain, shear modulus G is equals to F by A divided by delta x divided by H, which is equals to F into H divided by A into delta x. So this is the formula we have been done. So you can calculate, they have given G. So G is equals to F into H divided by A into delta x. So you can directly also, you can do it F into H divided by A into G, which is equals to delta x. So that's all. You can get the answer. Clear, Rudreshwa? Understood, brothers? So that is what you have to do it. So this is what is all about this concept. So the next concept what we are going to study is the most important one. So based upon this, that concept, 1 year they asked the JEE advanced, there is a question. So that is what a typical stress strain curved for a metal actually. So this is the metal for basically general substances I am saying you. So there is no fixed graph for stress and strain, but this is what is like an expected graph. So just generalized graph for this one. So this is a very important for JEE mains and as well as advanced also. So let us see now. I hope you all clear. So keep heading next one. Stress strain curve or stress strain graph. Stress strain curve or stress strain graph. Shall we start now, Pradosh? Yes. So we already studied that in last previous class itself. Stress is directly proportional to strain. So means in the sense of what? A force by area is directly proportional to three formulas for strain. What is that? Delta L by L, which is equals to delta X by L, which is also equals to what? Delta V by V. Am I right? Everybody? Yes, please. So stress increases, strain also increases. So that is what we all studied that. Now, before going to explain this concept, I want to speak some general things and then I'll come to the graph. Now, we all know we are having a good experience with spring. Basically, you can notice it. For example, I have given you a spring, a helical structure to you. So we can do the two things. We can apply the force in two different manners. What is the two different manners we can apply the force? Anybody can tell? All of you? So one is expansion. Am I right, everyone? So both the sides, if I apply the force, so just generalize, you imagine that. So initially I applied, for example only everything, 1 Newton force on both the sides. Maybe the spring length will come to up to here. Now, if I release at this point, again it will be back to the same initial position. Do you all agree with me, everybody? Are you clear? Now, if I increase the force to the next level, both the sides. Now again, maybe the elongation of the spring is up to here. So what is happening? Stress increases, means applied force is increases. Then the strain is also increases because both are directly proportional to what? Stress and strain both are directly proportional to each other. Are you clear? Now, or else you can take like a spring balance, attached spring balance. So now, for example, I can hang a first 1 kg mass. Now there is an elongation up to, let me take it as a x1 elongation up to here. Now if I release this 1 kg, it will be back to the initial position. Now I made it 1 kg become 2 kg. Now maybe the elongation up to here. Now at this point also, if I release it, again it will be back to the same position. So means in the sense of what will happen? Stress increases, strain also increases, keep on increases. One increases, another one also. Now, I suddenly made the weight into 10 kg. So then if you notice it, at this point, so already it has been reaches to the maximum elongation, means in the sense of the reversibility factor cannot be existed. Means after 10 kg, the spring has been stretched to the maximum length. It is not breaking. But it will, if you remove this 10 kg, it cannot be reversed back. Are you clear, Mr. Rudreswa? What I'm trying to say? Understand, Pradosh? Now, I increase the mass. 10 become 11, 11 become 12, 12 become 13, 13 become 14. Up to here, I have seen increasing the length of the spring. Means it is still extending. Before 10 point, means up to 9.9 kg, if I remove the mass, the spring will back to its original shape. But once it will start the 10 kg mass onwards, the spring is lost its reverse property, means it cannot attain its previous shape. So it will be like stretched one. Then 10 to 14 kg or 15 kg we can take it. So what is happening? Still the spring is keep on extending. But if you notice it here, from this point to this point, stress is not directly proportional to strain. So once it will be not able to reverse it, stress is not directly proportional to each other. So from the 10 kg, I'm taking every values as an example. From 10 kg to 15 kg, little stress will be increases, little, but strain will be very, very high for the spring. So strain will be more for it. Okay, like even more real life example also I'll say. Now, once it will cross the 15 kg, still it won't be break. But if you take it 15 to, for example, let me take it as a 25 kg. So the spring will be no increment, like length cannot be changes, but it can resist. That resistance, there is a word in physical properties. Can you tell me anything? Without breaking, it can be resisted. There is a word we can use it. Anyone? That is, call it as a tensile strength. So it can be uphold the mass up to 25 kg, but after 15 kg, there is no elongation, no extension of a spring. So now, once this is the maximum capacity of the spring holding, if you keep greater than 25 kg, the spring will reach us to the breaking point. So that is what we used to call it as a break point. So this is what is about the stress strain graph we'll speak about. So now, for example, even little comes to the more real life. For